Alright, so today we're working on some basic operations with radical expressions. Really going to do a lot of simplifying. And so let's kind of look at some general guidelines. Here's a key. When the square root of a and b are real numbers, okay, they have to be real numbers, then this property holds. You can just basically multiply a times b, throw them both under radical, or you can separate them if you want to. Okay, so for example, let me show you a real simple one. How about the square root of 36? Well, we know that's 6, right? Well, I could also break that up as square root of 9 times square root of 4, which is 3 times 2. Okay, that's 6. So again, just an easy example, kind of illustrate that principle. So let's simplify a few. Simplify this. Well, it might help. Let's just multiply them together and see what we get. Let's put them all under one radical. 3 times 3 is 9. F times f is f squared. G squared times g is g cubed, right? So let's just throw them all under the same radical and simplify. Square root of 9 now is 3. Square root of f squared is f. Now last lesson they had us put that in absolute value. Don't worry about it today. G cubed. Square root of g cubed. Well, I could pull a g out of that, right? And that's going to leave a g in there. So, because again, if this were inside, it'd be g squared times g, basically, and then I could pull a g out. How about this guy? Cube root. Now, cube roots are a little trickier, okay, but let's think about them. Maybe in this case, it helps me to break it up and kind of visualize what's going on. So, cube root. So, cube root. Now, 54. Let's see, 54 is the same as 27 times 2. Now, the reason I broke it that way is because cube root of 27 is 3. 3 times 3 times 3, so that's a nice one. Let's see, a squared, b, c cubed. Now, so cube root of 27, that's a 3, so we can pull that out front. 2 is still going to be in there. A squared is not going to simplify, b is not going to simplify, c cubed. Cube root of c cubed is just going to be c, so we can pull that out. Now I've got my cube root, remember what's left in there. So I've got my 2, I've got my a squared, and my b is still in there. Hey, we just simplified that a little bit. How about this guy? Now this is kind of similar to the first one, except it's cube roots. Let's multiply everything together, see what happens. So we've got the cube root, 25 times 25 is 625. V squared v, so that's v cubed. W squared w, that's w cubed, so that'll be nice. Alright, now 625, and again you could go play with the calculator, maybe I'll break that up. That is the same as 125 times 5. 125, which is 5 times 5 times 5, is a cube root, so I can pull that out. So I can pull a 5 out there, v cubed will just become v, w cubed would become w. So we have our 125, 5. There, remember we broke that 625 up into. The 5 would come out, because that's the cube root of 125, and then we're still going to have, I'm trying to find my pen here, then we'd still have the cube root of 5 left behind. So again, the v came out, w come out, and there's our answer for that one, okay? So, very similar, we looked at when we multiplied. Now what if you divide? Well, it's the same property, okay? So if you divide these roots, you can divide them into two separates, or you could write them as a single expression. So a couple examples here. Square root 5a, square root b. Well, I could just write that as square root of 5a over b. And there's really nothing else in this one to simplify, so just illustrating that property. Okay, cube roots, again, get a little tricky, but let's try these. So I could write this as the cube root of 64m squared over 4m. Well, let's simplify that. So 64 divided by 4, what is that? So what are we looking at? 16? So yeah, 16. So 16, m squared over m would be m. So cube root of 16m. And then we could simplify that just a little bit, because 16 is 8 times 2, and 8 has a cube root. So I could write that as 2 cube root of 2m. Again, if the 2 is inside, 2 cubed would be an 8. 8 times 2 is 16. So I think we could simplify it like that. How about this guy? Very similar. So notice cube root 3 over 3 is going to just divide out. N squared over n would be n. So I've got mn left in there is all. And that won't simplify. And so there you go. That's all there is to it. Okay, now sometimes it's advantageous, right? So it's helpful to eliminate a radical from a denominator. We call that rationalizing the denominator. We do that by multiplying by some fractional form of 1. Kind of like when you get a common denominator, you multiply like 2 over 2. But this time they're going to be radicals. So in this case, we want to get rid of that b in the denominator. Well, what if I multiplied by square root of b over square root of b? Notice square root of b over square root of b is just 1. Well, on top, I would have square root of 5ab, just using that multiplication property we just looked at. Now what's square root of b times square root of b? Well, square root of b squared or just b. Notice no radical on the denominator anymore. How about this one? Now with cube roots, it's a little bit trickier because we need to decide what can I multiply this by that's going to make perfect cubes. So it's not just square roots, you just look at whatever's under the radical, that's what you multiply by. For cube roots, we need to think about it a little bit. So on the bottom, let's see what we want. So we're going to have a cube root, so 3. So I need 3 times 3, so that's going to be a 9. And v squared, so I just need one more v, so 9v. So I'm going to multiply by cube root of 9v over cube root of 9v. So on the top, that would give me cube root of 18 VW, right? Just multiplying those using that property we just looked at. And on the bottom, I'll go ahead and just show it here, and then we'll work it out. So that'd be 27 V cubed. See where I'm going? So on the top, cube root 18 VW. On the bottom, cube root of 27 is 3. Cube root of V cubed is just a V. Hey, we just simplified that thing, okay? So you get a little bit of practice with that with the lesson. We'll also do more of that as we move ahead and get into future lessons as well.